A very good morning to one and all present over here in this 1 week FDP on the new age infrastructures, their analytical and design solutions. So friends and colleagues, I'm happy to introduce our first expert of this FDP, Dr. Ubagaram Jhonson Alengaram, Associate Professor, University of Malaya, Malaysia. So we are first of all very thankful to Dr. Alengaram for accepting our invitation and readily supporting this endeavor regarding this academic development of the faculty members. I have been in the conversation through emails with Dr. Alengaram sir, and I found that he wholeheartedly very much helpful for this kind of the gestures done by various academic institutions in India also. So, sir, first of all, welcome and thank you very much, sir, for your consent and being here with us.
Really appreciating your invitation and thank you.
Yes, sir. Thank you. Thank you very much, sir. So I'll not take much of your time of the session, but it's very much important that I must introduce our first speaker and expert with the participants. So Dr. Alengaram is the Associate Professor and the Director of the Center of Innovative Construction Technology Research Center under the Faculty of Engineering, University of Malaya, Kuala Lumpur, Malaysia. So, sir is also a chartered civil engineer of the world-renowned Institute of Civil Engineers and the Engineering Council, UK. He is also associated with the Institution of Engineers, Malaysia, American Concrete Society, ACI Kuala Lumpur chapter. And I just would like to add here that, sir, we are also having the ACI student chapter at our institute also. So it's a good coincidence again. So we'll continue our discussion in the future also. And the Concrete Society of Malaysia. Sir has received numerous research grants from the University of Malaysia, Malaya Research Fund and Ministry of Higher Education, Malaysia, national and international grants, including prestigious Newton Ubuku Omar Coordination Fund, UK Malaysia Research and Innovation Bridges Competition. Sir has been in the academic, consultancy, research and administration for over 20 years and contributed to the society in the different capacities in India, Bahrain and Malaysia. Sir has supervised many Master of Engineering Science and doctoral candidates to the successful completion of their degrees. Sir is current Web of Science H index stands 36, which I'm sure now by this time it must have been increased, with the publication of over 140 publications in the referred journal and conferences. Next, please. Amit sir, can we have next slide? All right, so with this introduction, I would like to once again welcome Professor Dr. Alengaram sir. And sir, it's all yours. We are all eagerly waiting for your expert session. So please do the needful and please take the charge of this platform, sir. Thank you, sir.
Anchor and all the dignitaries, your universities, officials. I'm so glad to be part and parcel of this program. In fact, it's an honor for me to be with one of my country's universities, one of the leading universities in Gujarat, Rajkot, where our father in Gandhi's place, Rajkot. It's a very important place for us in our history. Thank you, Professor Ankur, and you are one of the very, very hardworking and dedicated member of the staff. I think people like you can move our country to the very next level that we are all anticipating. Our leaders are working for us. So we have to move forward. Therefore, I thank you again. We need people like you who are very much into the focus of our future leaders from our countries, from our universities. So I'm so grateful and honored to be part and parcel of this program. And I'm from Coimbatore. We call Manchester of South India. Therefore, we work very hard, in our sites, very hard, like you people. So it's very important in Malaysia. I'm an expatriate lecturer, so I know the difficulties that we have to go through when you are working in a new country, another country. So I will share some of my experiences here, and allow me to share my screen, Professor Ankur.
Yeah, sure, sir. Amit, sir?
Yes, sir, it is alive.
Okay, now I'll try to share because now, yeah, I can. So let me share. Is it possible for you to see the screen?
Yes, sir, it's visible. You just need to go to the full screen. Yeah, that's it. Yes, sir.
Okay, thank you, Prof. Again, I'm going to start now.
Program.
Yes. You are organizing this program as part of the faculty development program. So I would like to know who are the participants, Prof. Ankur, who are the main participants here?
Sir, the participants are from the different parts of India. They are largely the faculty members, because we have offered this program to the faculty members primarily as a part of their academic training. And a few of the master degree students and the PhD students are also there as a participant, sir.
Okay, that's great. And let me start my session. Let me just move the screen down because that's the 1 minute. Give me just a minute. I have to move this because this is blocking. Oh, give me a minute.
Yes, sir. Please take your time. Yes, sir.
Okay, just move this. Now you will see my screen, full screen. Then
yes,
as you introduced, I am working as an associate professor, and also I'm the director of the research center we call Center for Innovative Construction Technology. It's under the department and the Faculty of Engineering, University of Malaya. It's the oldest university in Malaysia and also the #1 in Malaysia. It's called Research University. In my title, I paraphrase like this: Enunciation of Embryonic Construction Materials for Sustainable Development and Demonstration Project. Because we have done few projects, I will showcase here 1 or 2. Hope my voice is clear. Is it audible?
Yes, sir. Yes, sir. It's very much audible.
Yes. I'm grateful to all the organizers, including the Professor Ankur and your department, your faculty, and the university as a whole, and also inviting people from different parts of the world. In fact, I might have given this talk before, but I hope some of this information might be useful for those who are new listeners. Okay, it's a honor for us. Our university is now currently 9th in the top best in Asia, means top 10 best in Asia under the QS world ranking, because we follow QS world ranking, and also 59 in as of 2021 in the world. It means it's not that easy to get among 20,000 universities to be on the top. Okay, so it's very important. And we receive students from different parts of the world: China, France, India, and Bangladesh, or many countries. Visitors come and visit us. And we are so fortunate. We are having student exchange program with many universities in the world. And I remember in 2018 or 19, I think, from your Gujarat Technical University called LJ Institute of Engineering Technology, the student visited us. We have taken them to different places and also, showcase our research product. These are the students from LJ Institute of Engineering Technology under the Gujarat Technical University. Let me go to the background of this today. It's very important for civil engineers or mechanical engineers or any engineer or any person in a country. When we are involved, embarked in development, we need to concern about the environment, our planet. We need to also think of the prosperity of the people, and at the same time, the very people who are involved in the development, they need to be taken care. Prosperity of the nation and the people, those who are involved, and planet. So these three P are very important in our development, according to Elkington. He says, people, planet, and prosperity are commonly called the three legs of the sustainability stool. So by balancing our decisions over these three areas result in a sustainable solution. Because this is very important, sustainable. So this slide, I've been sharing this all over. Very important for us to know how US, the United States alone, with a population of less than 5%, consumes 30% of the world's total energy and 60% of the world's electricity annually. So this is quite serious, because we are talking about a conference, World Climate Conference. We are talking about sustainable development and so many things. However, the developed countries, they continue to release the GHS, greenhouse gas emissions, without any break. So thereby, we see even a small population with less than 5% of the population, they are consuming so much of electricity. And look at the buildings in the US. They consume 5 billion gallons of potable water. You can use this water for our daily need. It's not a wastewater. It's a potable water to clean the toilet, flush out the toilet every day. But according to the estimate, this water is sufficient for every person in the world for the daily usage. So the sustainability is a very important aspect. As for the developed countries, they are the one should take the lead for other countries to follow. And another principle that I always quote is from the Biomimicry Institute. There are 10 principles they outline, and some of these principles are guideline for us, even for me personally. For instance, I use the local resources in my projects, and we do not draw down the resources, general resources that are available. We should not. And we should run on information. This is one of the key. For example, in the Europe, there are 27 countries under the European Union. And if we want to get a data, how many waste collected from a household in Sweden or Switzerland or in other countries, probably under the EU, I'm talking about the EU countries, say France, and how many tons of waste are incinerated every day, and how many tons of waste are created. They do have a database. Unfortunately, if you look at our states, many states like Gujarat, they may have a data. But if you ask about where are the data from the other states, for instance, say Bihar or Nagaland or Manipur or Jammu and Kashmir, so how many tons of waste collected every day? What do they do with the waste? Do they incinerate properly? Do they store it in a certain place and they dump it or pollute the groundwater? So there are so many things that we need to think on the database. Without database, it's impossible for us to move forward in our research. So when we say use waste as a resource, the first principle outlined by Benius, it's impossible for us without the database. So this is what we are to think on. Those who are researchers here today, remember, I have been also trying, say in Malaysia, 400 palm oil industries. These palm oil industries do produce a lot of waste every day. So where are the data? Where is the information on the daily collection? How many tons are oil produced? Out of the oil, how many tons of waste? And what our civil engineering students or people can do using these materials? So according to this principle, biomimicry principle, she says that the successful organisms on the planet are those that have lived competitively thousands of years within the ecological system without consuming their capital. See, that's very important. Look at the marine lives. You can see nowadays through many channels, National Geographical Channel, Animal Planet, so many channels, they do bring out the miracles under the sea, under the ocean. So they have been living for years and years. They don't consume the capital. They do keep their capital. Why? They know how to sustain. They know the term sustainability more than any of us. They don't consume today and tomorrow. They keep on living for thousands of years. So when we think of ourselves, we are ashamed when we compare with the marine lives, the whales or the fishes or other, those who live in jungles. They do keep their resources for thousands of years and they don't consume the capital. But what do? Look at some of the information. Say LEED, I always emphasize on this LEED, L-E-E-D. This is third-party verification or body in the US, Canada, some of the Western countries. This is called Leadership in Environmental and Environmental Design. Leadership in Environmental Energy Design. So this LEED certification system, they evaluate any buildings constructed. They do incorporate electrical aspect, mechanical and electrical aspect through energy saving, water efficiency, and the carbon dioxide emission reduction. How many percentage in this, if we use this building, how many percentage they reduce the CO2 emission? Are there improved environmental air quality? Is there any quality of air inside, proper environmental quality, indeed interior? How about the master plan, the plan for the maintenance of the building? That's what called stewardship of resources and sensitivity to their impacts. Do we keep a plan? See, in developing or underdeveloping countries or the undeveloped countries, we don't have the plan for maintenance. For example, 10 years afterwards or 20 years, 30 years, do we keep a budget to ensure the building that we do or build? Do we have a master plan or budget to ensure that the building will last for 50 years, 100 years based on the design life? How do we maintain it? So sensitivity to their impact. This is what the LEED certification system does. They do have a system wherein they check what is your plan for maintaining this building, and you don't draw the resources again. And what about the environmental quality, indoor environmental quality? Do we have sufficient proper air? And do you save energy? Do you save water? Okay, these are the things. In Malaysia, we do have a certification system. It's called the Green Building Index. They do give us certain points. For example, energy efficient building, 35 points. Indoor environmental quality, 21% or points. Sustainable site planning and management, they do give 16 points. Material and resources, 11 points. So this is where we can come in the number one, because energy efficiency, it's not only doesn't lie with only the electrical or mechanical engineers. We civil engineers do have a major responsibility. For example, we are developing building materials that are thermal resistant, means when we use it for the exterior wall, we can save energy inside because we don't need to use these air conditioning, some of the buildings. We don't have to use the air conditioning or some other appliances. Why? The exterior wall is capable of resisting the heat, and they don't transmit the heat from the exterior heat towards the interior side. Same thing applies to the cold countries like the northern region countries like in Russia or other countries. They do, when they use this kind of the material, they ensure they don't need to use the heater during the winter. Why? The concrete, the building material they use is capable of resisting the cold wind or air to pass through the walls. So what do we do with this energy efficiency? We have a role to play. It's nothing to do with the electrical engineers. It's a civil engineer who have to design the material or so-called the building blocks or the walls to ensure that the exterior heat or cold wind, they don't enter into the interior of the building. Maybe a limited amount. Maybe we can't make 100% proof. But however, we can ensure that we allow certain amount so that the interior electricity usage can be reduced. So this is what we need to think on. And this chart, so-called the pie chart, gives you the cement consumption of various countries. China consumed almost about 57% of the cement used. I've been to China for quite a number of times. I've seen everywhere you see the cement, either through the tunnels or through the roads or bridges or through the infrastructure, multi-story skyscrapers, everywhere. You don't see any region in the China without cement. What does it mean? They consume 57% of the world's total cement consumption. And you see India, we are here, we have a similar population, almost 130 billion, 1.34 billion and 130 crores. And they do have similar. And the population wise same, but the infrastructure development is only, we are using 6.2% for our population. Of course, this leads to unsustainable means of development. Of course, we can see that. Look at this, the article I used to quote this many of the times. This is the blog, of the Bill Gates. He's nothing to do with the civil engineering. He's a computer expert. But he was writing an article in the Washington Post, citing the source from the US Geological Survey. He said, in the 100 years, United States used from 1901 to 2000, only 4.5 gigatons of the cement. Giga, giga, the number of zeros involved in giga. And here, China, within 2011 and 13, they consumed 6.6 gigatons of cement. Imagine the development and the usage. But one way this will show the superiority of the country's development. But on the other hand, we are losing the sources or the resources for that are meant for next 100 years or 50 years or 1,000 years. We are consuming the human capital. You may ask, what kind of capital we are consuming? Say cement, you need the limestone deposits for many hundreds of years for our grandchildren or the next generations, future generations. But we are taking it and we are almost dumping it everywhere. And the future generation can't find, when they want to find the limestone deposit, they may not find anywhere because almost everything is consumed now. Then also look at the sand in state of Tamil Nadu, where I hail from. I know there are shortages of sand in many places. They do use the quarry dust, which is pristine as manufactured sand. It's nothing but the quarry dust. We centrifuge it and ensure that these particles are angular and flaky particles are rounded off, and we can use it as a sand. So they are using it in many places, no choice, because there is no reservoir, no sand. And look at the development of China. This is the Shanghai, one of the district in Shanghai. This is like a Bombay of China. You see, the quick between 1980s and 2000, so much of development. So let me go towards this, inching towards sustainable development. What do we do in University Malaya? This is the #1 university in Malaysia and also top 10 in Asia and 59 in the world. How did it come to that level? It's not just by accident. Every researcher here, we are not only teachers, we are not only lecturing to our students, but we do involve in research almost on daily basis. This is what my heart goes to my country, India, because we can learn from small countries, Singapore, Thailand, Indonesia, Malaysia, and we can learn many things, not only from Western countries like UK or this US or Australia. No, we can learn from small countries. Doesn't mean we are not improving. We do a lot of things in India. I don't underestimate my own country. But what do I say here? We need to move forward in research and development, in sustainable concrete, in sustainable development. We are there, but we need to move forward. For instance, many of the universities, we are teaching universities. Only IITs and NITs and other institutions, we do conduct research. But Most of the other universities, also called institutions, engineering or medicine or arts and science, we do have most of this are limited to teaching. So we produce a lot of paperwork, not the products. We do a lot of certificates, but not the certified engineers who are qualified to change the destiny of the country. So what should we do? We should develop so many tons of waste are developed. But how do we convert into product and how do we apply it in the field? That's where we are coming. So industrial waste, you see here, a lot of industrial waste, we do make a research. We do conduct research in Malaysia. So these are some of the waste material like palm oil, clinker ash. As I mentioned, Indonesia and Malaysia, they produce 80 to 90% of the world palm oil. They do have thousands of palm oil industries. So what do? They do produce these kind of waste in Malaysia. So these waste can be used as a cementitious material. So we do use it. So in India, we have a lot of quantities of fly ash. Of course, they want to shut down the coal-operated power plants. Maybe in the next 30 years or 50 years, they might not use the coal-operated power plants. But till then, what do we with the coal? After burning the coal, we are still using the coal-operated power plants in many parts of India. So what do? Of course, we use the fly ash everywhere in construction, no problem. But what about other ashes? Municipal ash, we are incinerating the ash. What do we do with the municipal ash? We can use it somewhere. What about this kind of any other ash that may be available in India, in Malaysia and Malaysia and Thailand and Indonesia, Nigeria, Ecuador? These kind of ashes are available. There are maybe 10, 20 countries. They can use this kind of ashes in the concrete. We do use palm oil fuel ash. Both are A and D. They are originating from the palm industry. And the bottom ash, coal-operated power plants, fly ash and bottom ash. Bottom ash is not commonly used. Fly ash is very well used in cement industry. What about the bottom ash, coal bottom ash? We need to think of that because I've been to a few plants in Malaysia. I've seen millions of tons of bottom ash. Just they dump it on the open area. They don't use it because it's called scheduled waste. They don't allow it to be just used as a building material. But we researchers can think of. So when we have tried it as a powder form in the ash format. It's quite usable. It's working. It's a pozzolanic. You can see that in the next slide. See the bottom ash. You see that it has a 50%, nearly 49 or 50% of silicon dioxide, aluminum oxide. So it is quite, when you consider the silica alumina iron oxide, SAF, it's 70% almost. It can be under the old ASTM classification, not new, the old ASTM classification. It can be considered as class N and class F. So this is very useful. Bottom ash, fly ash, we all know. GGPS is another, blessing to our cement on construction industry. With this, we can do wonders. Ground granulated blast furnace slag. This is the new palm oil fuel ash, palm oil clinker powder from the countries like these, the tropical region. They do have this kind of ashes and rice as ash. With this, I think there are other ashes, metakaolin we have from the clay, and there are other byproducts from industry. Okay, so this is very, very important. And of course, if you look at the laws on ignition, this is LOI is very important for civil engineers. We need to think how we can improve. This one is quite high, this one. But others, for example, this fly ash is very small. It's all considered pozzolanic material. And in addition to this, we do also have these aggregates from the palm oil industry and incinerated bottom ash. This one, we can use it for pavement blocks, incinerated bottom ash, because you are collecting millions of tons of waste from the households every day. They burn it, they incinerate it. Later on, what do they do with the powder, with the salt? Maybe it doesn't have the quality, so-called the chemical composition, but it can be used as a filler or aggregates in the, let's say, non-structural elements. For example, pavement blocks on the roads, on the walkways, or certain place where you change it every 10 years or 20 years. We can use this as a fine aggregates as well as the coarse aggregate if we have the sizes. And these are the things we have also used in some of our projects as well as demonstration project. We can see the properties, physical properties here. Okay, I'm going to take you through few projects that we have constructed. We call it as a model house, greenhouse. We have built using some of the products, say materials we have shown here. Some of these materials have been used and these aggregates have been used. See, for example, this is from the steel industry. Steel industry, they produce a slag aggregate. Slag aggregate, the specific gravity is quite high compared to this lightweight aggregates or normal weight aggregates. The steel slag aggregate is quite high, but we don't use it in superstructure because of the dead load, heavy dead load. We can use it for these substructures or others like pipes or others, say precast elements for the ground floor or beneath the ground. We can try to use this kind of slag aggregates. It's a heavier aggregate, but it is quite useful because this is very used in the developed in the steel mills, steel industry. So I'm going to take it. For example, we use some of these materials in this demonstration also. Of course, we do work with many industries, which Marwadi University also does, and also many of our Indian universities nowadays. Without industries, we cannot work, and also the overseas universities. Now, maybe your university has a lot of collaboration overseas, I know, but we can move forward to work with more. This is only selected industries. We work with the UK government or Malaysian government or some of the private companies you can see, and some universities, just selected universities. Of course, we have a collaboration with many universities. Our university has a lot of collaboration with the overseas industries and universities. Okay, based on this slide, you can see that we are concerned on the depletion of virgin construction materials and natural resources. This is a very serious issue. You and me have to think. We have to pause. We need to think how we can inform or inculcate this serious issue to our next generation. Probably we need to teach. I saw some of the documentaries in Sweden or Switzerland. They do teach this to the kindergarten students. Do you understand? Even the kindergarten students, they teach the sustainable aspects, even collecting the dust and properly storing it in certain place, segregate the waste, plastic separate, bottle separate, the paper separate, so that they can recycle it. Kindergarten, they do have a syllabus, sustainable means, or how we can avoid the overuse of the materials. When you are inculcating such habits, even at the younger age and to the younger generation, I think we are in the right track. So we should think in our governments, our state governments as well as the federal government should think of how we can inculcate this kind of habit to the kindergarten or the schools, the sustainable means, natural resources. It can be for handphone or a laptop or any of these things, electronic items or construction materials or mechanical items. We all use the natural resources. So how come the depletion of this can go on? See, the building industry alone, nearly 8% of CO2 emission from the construction industry. Rising cost of the building materials and weaker economy. Every day we see the building material cost rise. And I don't think the cost is going down. Rather, it is rising every day. And this, even the state of Gujarat, what is the population? Look at the state of Uttar Pradesh and Bihar, and look at the biggest states in India. How many people are in need of house? There are millions and billions of people waiting for a new shelter for their head. Are we having enough resources to meet this need? Okay, and the government is now implementing everywhere in the world green building matrices. For example, without certain green building elements, they don't allow you to construct because of these aspects. For example, we are running out of natural resources. Okay, may I pause for a minute? And am I talking to the audience in a clear and clear voice as well as clear terms? Am I talking to you properly? Can you hear my voice clearly?
Yes, sir, it is well audible.
Now, as I mentioned, as a civil engineers, we are not only the engineers, we can also be marketing people. We know the database. All we need is a database, and we need to have the proper linkage with the construction industry. And easy in Malaysia, a small country with a 30 million, 32, 34 million of population, 32, 33 million population. It's less than a Kerala, size of Kerala. So this country has a lot of waste materials or industrial byproducts. Quarry dust. Nowadays, they are Christian as a manufactured sand. No more quarry dust. Still, they are using for the roads, the laying of the roads, the subways. But we need for the superstructure. So people started using the manufactured sand. So as I mentioned, the slag aggregate, we are getting also million tons per year. Singapore comes to the Malaysia because they don't have any resources. Singapore is the country. They don't have anything, but they are the number one in superpower in the Southeast Asia. Why is it? Because they know how to get materials from different parts of the world, and they are economic giant. But they don't have any natural resources. Even water, they do depend on Malaysia. The sand, they don't have any sand. They don't have any reserve for forest reserve, nothing. A small land or piece of land, just it's an island, along 40 kilometers, 40 by 40, maybe very small island. Why they can be a superpower in the world? It's because they know how to utilize this slag aggregate. It's a product produced in Malaysia, but they come and take it. They use it for many purposes, slag aggregates. And of course, the sand is not available to them. So they do use this manufactured sand, just the quarry or take it from any other regional countries. They don't want, because there are many bans on import of sand to other countries. Some countries, they don't want to export the sand. So what does Singapore do? They are so sharp in their thinking. So what do? They just centrifuge the quarry dust and they make it as a rounded aggregates, fine aggregates. They do as a sand for basis. They do have this palm oil industry. It's going to come up. Maybe in future, we do have this kind of waste from our palm oil industries. And fly ash, of course, we do still depend on the fly ash from the many coal-operated power plants. Okay, so in our project, we did say, for example, we used manufactured sand and quarry dust as a fine aggregate. Coarse aggregate, we use palm oil clinker and palm shell and slag aggregate. We did use in our construction of low-cost house. I will just share the short video how the project, and also for the cement replacement, we use the GGPS, we use palm oil fuel ash, we did use a fly ash, we did use a palm oil clinker powder in this small construction of the house. So these are some of the materials that we used. These are the materials that I mentioned before, the slag aggregate and the palm oil clinker aggregate. This is a very light density of a specific gravity of 1.7, 1.8, but this one is 3.something, 3.15 or 3.2. This is specific gravity. And these are the powders or so-called ashes that we used in the construction of the low-cost house. We did use for the raft footing, we used this palm oil clinker powder as a cement replacement material. And for the pavement, we used the palm oil fuel ash in a geopolymer pavement. And for the fly ash, of course, we used in these two mixed for the pavement. And this also we used in the pavement, the ground granulated blast furnace slag. Of course, when we involve in project, we can't do it in the laboratory because it's very small in laboratories. It's impossible for us to work with the construction projects. So we did approach a company called by IBS Asia, and they have opened up the factory for us to produce this kind of blocks using our materials. They did help us. So based on their help, and we manufactured these bricks and blocks from that factory, and we brought it to the site, and we did use in the construction method is very simple. We use the footing of the location. We couldn't go for the other footing because the location given to us car park. In the car park, we are not allowed to dig the bitumen So they were asked to just place it on the car park. So therefore, we need to use the raft footing, then reinforce U-brick beam and the column blocks for the columns, and brick wall and the metal deck roofing. Very simple because the budget is very small. So once we were given the task of this car park area, this is so you see the building here. This is the car park area. It was a car park. So we had to use this car park. We did the raft footing. So the aggregates that we used here, 100% slag aggregate, heavyweight aggregates. And the cement, we reduced 15% of the cement using palm oil clinker powder. And we did manufacture this block, this one using the steel slag aggregate, also the oil clinker aggregate. These blocks are sustainable blocks. Becomes all in aspect. You can ask that, like, anybody can do this kind of construction work because it is not so complicated. So we need just the paste and just alignment is to be checked. This kind of construction, you don't need any sophisticated construction knowledge. Okay, this is what we.
Participants, I think the internet is troubling us, so please bear with us. Within few minutes, it's highly hoped that within few minutes we'll be back. So please bear with this interruption. Amit sir, I think it's the connection issue.
Yes, sir. It is a connection issue.
All right. All right. So we all understand this very well. So please bear with us for a few minutes.
Hello.
Yes, sir. Yes, sir.
Professor,
Yes, sir.
Because my internet gone. I'm very sorry for that. I'm sharing again.
Yes, sir. We understand.
Sorry for this. I was talking then.
Yes, sir. It's quite.
Are you able to see now?
Not yet, sir. I think you need to share your screen once again.
Cable, I think, issue reported, but it's too late. Okay with this now? Can you hear me?
Yes, sir. It's coming up. Coming up.
And please check. You are able to see my screen.
Yes, sir. I think it's coming up, but taking some time.
Oh, okay. Maybe my side internet is slow.
Maybe, yes, sir.
Okay, I'm sorry.
Not an issue, sir.
Okay, sorry for that.
It's a little slow.
I'm sharing. I'm trying to share it. I'm already sharing.
Yes, sir. We are back on the screen, sir. You can go to the more.
Are you okay? Now, see?
Yes, sir. It's perfect now.
Please let me know once you.
Yes, sir.
Okay, thank you again. You can hear my voice?
Yes, both, sir. Slides and voice, both are excellent. Please carry on.
Thank you, sir. Yes. So, okay, now we have constructed a small house. What you see here, 3-bedroom house, and with attached toilet using this. And also we had to use a very small budget. So we have to go for the metal deck. This is meant for the low-cost house. So we did using the sustainable means, and you can see that after construction, this house for school students, even within the university campus, our researchers are using it just to ensure that this is kind of technology we need to showcase to the public. Many people from different parts of the world, from America, from Australia, from Bangladesh, from India, from other countries, they come and visit us. We take them to the house. We say that this is the research output. We don't just conduct research in a paper format, but we do output. We have output of research by means of this, or even we are planning to construct a bridge using cement-free geopolymer concrete. These are some of the things. So you can see this short video. Maybe I reduce them now. Can you hear the music also coming together?
Yes, sir. It's coming up.
in Malaysia, there are people living in jungles. So, they don't have toilet, they don't have facilities. So we thought of having our project extended to them, some kind of outreach to the community. These people live in jungles. They are living in forest area. They are called, Orang Asli. We thought of reaching out to them. Even Netherlands and other places. Okay, let me go to the next one. I'm going to show you the next project that we have done. It's not the like construction project, but we use the local industrial byproduct as a blast resistant concrete. That's what here we are talking about. So let me go through quickly. In I have until how many hours, minutes I have, Prof. Ankur?
Yes, sir. It's we should close it by 5 to 11. Like up to 11 o'clock, we can definitely.
What is time now? What is time now?
Yeah, it's 10:20, sir. So I think we have around 30 minutes
Okay.
to
We run through faster.
Yeah, because we'll receive some questions also in case, because I'm sure that many people must have some questions to ask.
Okay, I will run through quickly. Okay,
Yes.
This is the palm oil plantation you can see in Malaysia. So they do have this kind of fruits. This is from where they extract the oil. You can see after extracting the oil, there is something called a nut here. This is the palm kernel shell. They have to break it to get the kernel. This is another oil. They take two kinds of oil. One is the cooking oil from the fruits skin. This is the after extracting. This is the from this using this skin. They do get palm oil from here. Then the kernel they do get kernel oil. This is also expensive oil. They do use it in many purposes. So if you see that these are the production of the palm oil. This is the shell, kernel. I see this shell, the brown color one. The yellow color one is the fruit. They take palm oil. The white color one is called kernel. They took extract kernel oil and the shell, they dump it in the factory. So we do get millions of tons of this waste dumped in the factories. So we do take it, it comes in a different shapes like concave, convex, and so on. So we did test compared between this aggregate and this aggregate. This is the normal weight aggregate, the shell aggregate. This is actually biodegradable material, please remember. And the density is only 1/3 of half of this, whereas the aggregate impact value enabled us to understand that this is having a lower value compared to the high value of the normal granite aggregate. So we try to use this property, and we did manufacture concrete. You see the density between this and this normal weight concrete. The density is around 2,300. This lightweight concrete, shell concrete, we manufactured with the 1,800. So with the compressive strength comparable, even though this is 30 and this is 37, this is likely higher because we use silica fume, and we managed to get this compressive strength for manufacturing in the concrete. So we see the slump values or compressive strength, and this is the shell configuration. And we did test the microstructure of the shell. This shell, the surface, how many pores? These are the tiny pores which absorb the water inside. So we check the surface. This is actually 20 micrometer, 15, 18 micrometer. You see, this is 50 micrometer. So you can see this can be 10 or 20 or 30 micrometer. This is what you see. You can see the filled one is the cement particles. Some of the holes not filled with the cement particles. So because of this, we added silica fume particles. Then you see that more or less all the holes are filled with the silica fume particles. So this enabled us to get the good bonding between the aggregates and the concrete. So you see here, we fabricated the beams, and we tested the beams in the laboratories, and we noticed that these beams, this is normal weight concrete beams, and you see here lightweight oil palm shell concrete beams, they do have a lot of cracks, meaning to say this is a ductile compared to this normal weight. This is a brittle, but this is a ductile beam. So this enabled us to check various properties. So we don't have time. We compared the cracks. So you see the oil palm shell lightweight concrete beams, they do have a larger crack width compared to this, because this one breaks. After this, they break or they crush. But this one then, because of the ductility, it can extend. So this one I don't have time to explain. But however, from the graph, we can see the lightweight concrete beams that were using the oil palm shell as the coarse aggregate. We can see the deflection even up to 80 or 100 mm. But here only 40 to 50 mm, because this is not ductile, whereas this is ductile. That's why you see the strain also, instead of the normal weight concrete, only 2,000 to 3,000 micro strain. But here we managed to get 8,000 to 10,000 micro strain. That means the yielding of steel continues because of the bond between the aggregates and the concrete and the steel, and also the elongation property because of the ductility of the beam. The steel elongates still because of the strain is quite high. Even the concrete strain, you can see it's quite high in the beam. So we compared with the different codes of practice, and we used that to our next project. This project is very interesting, that we did develop a blast resistant concrete using that. So we manufactured the slabs of 1 meter by 2 meter slabs, and 150 mm, 120 mm slab thickness, and we sent it to the testing site in another country, China, Holudo. We have our collaborator from the University of Adelaide, Melbourne, and they do have University of Adelaide had a facility. So we sent our slabs there, and we try to test it using 10 kg TNT. This Professor Zha is the expert in the bomb. He can handle the explosives because he's a trained and licensed. So he has helped us to have this is the actual the explosive 10 kg TNT. So we had a standoff distance of 1.5 meter height. It's quite close. This is the explosive charge, and 1.5 meter standoff distance. And we did test. You see the two comparison between the normal weight beam or slab, almost shattered. Nothing left after the test. But you see the lightweight concrete, it can withstand the blast after the 10 kg TNT. This is the blast, ignition of the blast. You can see blast waves and the impact, pressure, and the fire. So this slab, even the biodegradable, and it is just it can be burnt to ashes. The shell concrete can withstand the fire, it withstand the pressure, it can withstand the impact. So this is what you can see. Short video of this one. You can see that. Okay. This is the slab fabrication in the laboratory in University of Malaya. This is a test carried out at Uludu, China. This is after the ignition of the explosive. You can see the fire, the impact on the slab. This was captured using the high-speed camera. And this is the impact of the explosive. So we did two slabs. One is the normal wind aggregate slab. Another one, that one has almost shattered after the test. It cannot withstand. It couldn't withstand any of the impact or blast. Because you see the exposure of the steel even and a lot of shrapnels. These are the shrapnels. And the slabs become unusable. You couldn't expect anything from the slab after the damage done to the slab. This is the second slab that we used using the oil bomb shell concrete, lightweight slab. See, this is after the blast. See, there are same 10 kg TNT. See the impact and the blast hitting the slab. But we can see that the slab is intact after the explosion, after the test. So what does it show? That means the slab is capable of resisting the slab, the so-called impact, blast, and pressure. So this is very interesting for us. The slab was intact even after this one. So since I don't have time, I'm just stopping here. I'll go to because you see that a lot of these are fibrous. That is why we researchers are there to understand the material characteristics. How does it behave? Why did it behave differently compared to the normal concrete? Because it has the ductile characteristics. Why the ductility? Because of the the fibers. You see these fibers, they enable to absorb, receive the impact and absorb the energy. That's the reason it was so this. So next one, we also did another project. Actually, your students from Gujarat, they visited us when we were constructing this cement-free house. Even though I don't show much, just 1 or 2 minutes, just show this. This is very important for us to show that we need to replace cement with some of the alternative binders. So in Malaysia, we do have fly ash, and as I told you, some of the powders or the ashes. Instead of water, we do use the alkaline activator. In fact, we are producing, people have started using the rice husk ash as an alternative so to the conventional commercial silicate, sodium silicate. So we are trying to extract from different sources. Glass colored, people have been using, our researcher in the UK, they are using the glass colored because they do use a lot of glass. Every day, hundreds of thousands of bottles of this, they use for different purposes. They are just dump it. So they do recycle it and they extract the silicate from that glass collector. In our countries, we do have a lot of rice husk. So we can use the rice husk ash to produce this alkaline activator. Then instead of this river sand and mining sand, we can think of alternative sand. Instead of crushed granite or other sources of the natural resources, we need to think of other kind of materials. That's what we do. See here, these are the conventional, we need to put across, and we need to think of the alternative materials that we have shown here. As I told you, we do test on the shear, flexure, and you see that we have done with the help of our overseas collaborator, Adelaide University. We did a test on the shear block here, what you see on the left, top and bottom. And this is the flexure performance. This is another shear in the beam. This is in the shear in the block. So we did test all these things, and we did construct a house. This house, you can see here the background, we did use the geopolymer panels. So just we didn't use any cement. We did manufacture the blocks, and this concrete also plastic aggregates. We did use the plastic aggregate here for this panel. So this is me when I was inspecting we regularly did our own, our researchers as well as our own, we had a company collaboration. They provided the funding for us, and we did construct this house. So this was constructed just a couple of years back, and this is a cement-free house, and you see there are a lot of buses here, probably 30-40 buses parked here every day, and the drivers used to stay somewhere in a cabin here nearby. So when the Deputy Vice Chancellor, our former Deputy Vice Chancellor, Professor Rafi, informed us, why don't you use your research output here for the bus drivers? So we did construct this house without cement. And this one you see here, this is a plastic aggregate payments here. So very sustainable. This house this can last for probably many years because we did use columns and beams even for a small house using our concrete. So this is what our project outcome. So we did construct this, and the company, this is the French company, they provided funding for us. This is the managing director, our deputy vice chancellor inaugurating. This is me on the right side. So with that, I say thank you again. I'm on time. I have probably 10-20 minutes time or 10 minutes to answer your questions. Thank you very much.
Yes, sir. Thank you very much, Professor Dr. Alengaram, sir, for actually sharing the facts and figures to what generally the researchers and faculty members are always seeking. And I must say that, sir, you rightly integrated your session with the central theme of modern infrastructure, because these are the materials which are very well expected to come in full-fledged production on the industrial basis in near future, because we all are somehow the stakeholders and responsible people who must work on the sustainability primarily, and that's what the point that you rightly have triggered for all of us. So I must say that, sir, it was a very informative, very interesting also, and very much encouraging and inspiring session from your end, sir. And we on the behalf of the department and the university, I would definitely would like to express the gratitude and a sense of thanks to you for sharing your valuable time with us. So, sir, I think we have a couple of questions here. If you have few minutes more with your busy schedule, if
no
you can.
worry. No worry. Please go ahead. Go ahead.
Yeah, sir. Yes, sir. So we have with us Piyush Mehta, and he's asking that have you investigated the time-dependent properties such as shrinkage, creep combined with porosity measurements and mechanical investigations for oil palm shells concrete? So I think yes, sir.
Yeah, it's a good question. Thank you, Prof, for Prayesh. It's a good question also. We did investigate, not a creep, but we did investigate shrinkage. Shrinkage is because it's a biodegradable material. So shrinkage is slightly higher, but it's comparable and it's okay. However, the other one, for example, the durability aspect, we need to treat this shell because it's a biodegradable material. Therefore, this after treatment, we can use it for the shell because it's the water absorption is 20% compared to 1% for the inert conventional crushed granite. Therefore, it is having a durability issue. But what we are thinking, this oil palm shell, you can't use it for houses. Not even though the people have constructed a house in Malaysia and in Nigeria, this one can last for many years. But the water absorption is the one problem. For what I would say, as for the shrinkage, time treatment is shrinkage is done. It's comparable. It's not an issue. But creep, we have not done it. But the durability aspect, porosity is linking to the durability aspect. It has a durability problem because it is a water absorbing material. Therefore, you can't expect this to behave like a normal concrete. Therefore, what we are planning, this concrete, oil palm shell concrete, we can't use it for conventional structural grade, but rather impact resistant. For example, you are storing bombs, explosives, the gas cylinders. There is a possibility of sudden explosion. So we need some temporary protective structure, say walls or panels. You can use this material for 5 years, 10 years, you replace it. We don't expect this kind of material to last for 100 years. But say 10 years, 20 years, you have a panels, lightweight concrete panels. When there is an explosion, instead of the explosion relieving, there are many small fire cracks, plants or others. So when we want to protect the neighbors or the surrounding, we can use this kind of material. This is our aim, our understanding on this concrete. So that's the answer for this, Pius. I don't know, I answered you. Please feel free to ask more. Okay, the second one. Prof, you want to read it?
Yes, sir. I think there is a similar question regarding the physical properties of palm oil clinker. And there is a question that have you investigated on the fatigue strength of palm concrete?
Okay. The question from Zaid, I think Yashwan. Yashwan
Yes.
is from there. I can see that physical property. Yes, we have the physical property. Some of this I have shown you before. If you want, I can share, especially the clinker. Clinker can be used. I'm sharing it again. I'm sharing here. Give me a minute. Am I sharing the screen, Pro?
Yes, sir. I think you can share the screen.
Don't you see the screen, Pro? Ankur?
No, sir, not yet.
Okay, I will share it again because this is a very important question. What happened is my internet on and off. So, yeah, I don't know why it's today. And I
Yes,
was
it's coming up. Yes.
Yeah, I'm about to go to my house because this my office sometime has a network issue recently. Not normally, this university is a very good, but my block is a very old block, 70 years old building. Okay, now I'm sharing. Am I sharing the screen, Pro?
Yes, sir. Yes, sir. Okay. It's visible.
So for the question of this one, Yashwan, this is the property. For example, clinker can be used as an aggregate or powder. We crush it to the powder. When we crush it to the powder, you see, it can be considered as a class C based on the ASTM. Means 50% of silica. You can see that. I think I'm blocking with the question. So you can see that there is a 50% of the this silicon dioxide. So we can have this one can be used as a filler. If the pozzolanic activity is not much, but we can use it as a filler or even pozzolanic to a certain extent. We have done it. So this is the palm oil clinker as a powder, means I can use it as cement replacement. I mentioned to you during presentation, 15% of this used as a cement replacement for this. Say I'm just sharing here. Say in this place, this one, you see my slide. This basically for this place, 15% means only 85% cement, but 15% of this powder. We can go up to 30%. It's no issue because this is, if you see the chemical property, because I have time, I'm explaining more. So if you look at this LOI is only 0.78, or because it is burnt at probably 600 degrees or 400 degrees Celsius. So it is like after burning, what you get is the clinker. Therefore, this is a pozzolanic plus this filler. Also, this if you see this the physical properties here, this one clinker here, 1.8 is the density. It's very low compared to 3.15 and 2.6. See, compared, and also the water absorption is slightly higher. You can add more water because of this. And this one, you see, the aggregate impact, of course, it cannot withstand because it's like a porous. It's a very porous. So that's my answer for this. What is called Ashwan. Then I can see another question.
Yes, sir, regarding this is a question from Bindu, and she's asking, I think, or he's asking about fatigue strength.
Yeah, yeah, no, Bindu. Thank you for, maybe we can work together for the fatigue strength. I have not done the fatigue strength. Of course, it's a good point because it is when you say fatigue, it is cyclic loading. It will be very interesting. We need some project on this. It's a very good question, Bindu. Really, I appreciate. We can think of working together for this kind of work because somebody has to start this. So fatigue means it's a cyclic load. It can really withstand, and because it's already ductile material, you could have seen how the blast waves can be absorbed by this concrete. Surely fatigue is another interesting feature. It's a very, very good point from your side. I'm looking forward to the grant budget because even I'm trying to use it for missiles. When there is a missile coming and attacking the building, this can, withstand. So we are trying to investigate the missile strength or resistance strength of this kind of concrete. The fatigue is another interesting area. Bindu, if you are here with us, thank you again for highlighting this very important question, and I thank you for your highlight. Then another one, I don't know, Bindu is a professor or a researcher, I don't know. Anyhow, I thank you again. Then I have Sharma, Malhar Sharma, is there listen, why oil palm shell survived even after 10 kg TAD? So that's why you can see, I mentioned one point. Okay, see, I have mentioned in my slides, Very interesting question, and I've addressed this to some extent. See, this is a fiber. It's a fibrous. Okay, so it is the last slide. I have shown it. Why it can withstand? Because it is having here ductility. Because you see, I think I should show before this point. This point is important for you and me to understand. If you look at this, am I talking to Malhar Sharma?
Yes, sir, you are addressing his question. So
Okay.
please carry on.
I don't know, he's around to listen to my answer. Okay, should be around, I hope.
Yes.
This one, you see, this one, aggregate impact value, Sharma, it is almost 16% if you see the normal weight aggregate. But if you see this lightweight, it is only 4%, less than 4%. So that means, impact means, if you are familiar with the impact, we are dropping a hammer of certain weight, about 500 mm height, drop. Then you measure after a certain number of blows, you are measuring the amount of the crushed particle passing through certain sieves. That's called aggregate impact value. The codes, there are different codes. You need to understand which code you follow. Of course, the procedure is same. So when you measure the aggregate impact value, this does not crumble. The shell can absorb the impact, number one. This is the one enabled us to go. Next one, if you make the concrete and you see the deflection of this one, the deformation, this is the number of cracks here. See, the number of cracks in the shell concrete is double than the number of cracks in this normal weight concrete beam. What does it mean? That means the concrete is having the bond characteristics, and because it has a concave convex surface. You see the surface? It's a good question. I think very important for everybody to understand. See here, you have a concave surface. You have a broken surface. You have a convex surface, a concave, convex, and a broken surface. All the three surfaces behave differently. So when you mix in the concrete, these surfaces, see, this is the broken surface, and there are tiny pores, millions of tiny pores. These tiny pores are having a size of 20 to 30 micrometer, and you are filling those pores. See that this is 18.25 micrometer, this is 23 micrometer, this is 27 micrometer. These pores are filled with silica fume particles, very tiny particles. Silica fume is 100%, 100 times finer than cement particle. So what happens here? They are so fine that means they can fill, and the bond between this surface, bond between this convex and this concave surface and the mortar. Mortar means, you know, the cement and the cementitious particle with the sand, they bind together. This is number one. Number two is when these surfaces I mentioned here, I don't know, you have seen it in the blast. See here, there it's a fibrous, lot of fibers, they act as a fiber. So this fibrous characteristic of this OPS, they enable them to withstand, not to crush, not to crumble, but it absorbs the energy. So this is what we identified in this one. Okay, that's the answer to Sharma. Please feel free to ask if you have any other questions.
Yes, sir. I think the questions are done, and I think all the participants, fortunately, they have received a very informative session and interesting session from your end, sir. And I must say that we are fortunate enough to have your time with us, and I think let's hope that this the pandemic gets over by the next year, or somewhere around in the middle of the June, July 2020. So where we can expect you to, we will be grateful to you if you can spare a few days with us here, and we would like to have you at our campus also for your guidance, for your all the future endeavors, academic endeavors with us. And it will be our pleasure to welcoming you at our campus, sir, whenever it is possible. And definitely we'll carry on this this wonderful start to a very fruitful endeavors in future also. So with this note, I would again, on behalf of university and department, would like to thank you, Dr. Alengaram sir, for sparing your valuable time and resources and information with all of us. And I'm sure that this was a very wonderful start for everybody. And there is again similar interesting facts and figures are waiting for us to come in the next sessions. So before we go for that, thank you, sir, for your valuable time. Alengaram, sir. Yeah.
Thank you, Prof. I would like to also take this opportunity because I have 2 minutes or 3 minutes to just say my gratitude and thanks to Professor Ankur and the team in Malaya University. First of all, it's my pleasure because I say this is not a normal just training program. In fact, I do go to many universities. I went to Assam, I went to other states in Tamil India and Andhra, Tamil Nadu and other Telangana. So I used to share my experience. What is the importance? We as academics, we have a role to play. Research collaboration, industry linkage, and research output. Our young students from the universities, they are not only simple paper graduates. They must have motivation to change the nation, change the construction industry. So what we can do, Prof. Ankur, it is we meet together, maybe online or even face-to-face. When we have opportunity, we should work together. This is my ambition because I'm an Indian, basically. I work in Malaysia with a faithful, loyalty to my University Malaya, the country where I serve. But at the same time, it is my honor and pleasure to go back to our place and share the knowledge so that we win-win situation. Thank you again. Thank you for this time.
Rightly, sir. Rightly said, sir. So it was a wonderful session from Dr. Alengaram, sir. And now we, with permission of sir, we will close the session. And thank you very much again, sir, for sparing your valuable time with us. Thank you, sir.
Bye-bye.
Thank you, sir. So for participants, we'll begin our next session at 11 o'clock. And
yes, sir, one announcement, sir.
Yes, sir, please.
So, sir, from 11 to 11:30, we have a central inauguration program from AICT ATAL Academy. So all participants are required to join the program, and link we have already sent.
Okay, great. So we have a news that regarding the another official inaugural session, which is conducted centrally from the Academic itself. So I request all the participants to be there and grace the occasion, and then we'll carry on with our upcoming session. So thank you all participants for remaining present, attending this session, and we'll meet again at 11 o'clock sharp.